Hello everyone, my name is Tuhin. This is episode 7 of LangGraph series. So today we'll be building a smart reflection agent in LangGraph. So today's agenda, we'll be learning what is reflection agent, what are the difference between React agent and reflection agent, and finally we'll be building a reflection agent and we'll see how reflection agent works. Now what is reflection agent? In episode 6, we learned about React Agent. So React Agent is a framework for building a graph-based intelligent agent. Now Reflection Agent is similar kind of framework, which is a quite popular framework for building graph-based intelligent agent. So our Reflection Agent that is not only acts like normal agent, but it also reflects, means it introspects in its own past outputs. It evaluates them and then improves them. So you can think of it giving the agent of a feedback loop. So first it will generate a normal answer, a draft answer. Then it will reflect on that answer, that is introspect or evaluate on that particular answer. And based on the given feedback, it will improve the output. These steps, so revise and reflect, will continuously loop until it generates a satisfactory output. So this makes agents more reliable, self-correcting and iterative. So these kind of agents are more useful for specific kind of tasks like writing, summarizing, coding, reasoning. So LangGraph provides patterns to implement reflection loops. So you can design a graph where user makes a request to the agent. So you can see it here. User makes a request. So it makes an LLM call and generates an initial response. Then it can optionally execute tools. And then on that initial response, a reviser will be there. And reviser will be evaluating that initial response. If it looks good, then it will end that loop. If it does not look good, it will continuously repeat here until the result is satisfactory. We'll come to that in more details when we implement. Now let's see what are the difference between React and Reflection Agent. What are the different use cases for the React and Reflection Agent? So React Agent combines reasoning, thinking step by step with acting. So it is more useful when we need to use tools. We need to call external APIs through tools. And Reflection Agent is kind of continuously improve any response that is generated by the LLM. So it's kind of steps like generate, critique and revise and continuously loop until we get a satisfactory result. The main purpose of it is let the agent reason about what to do and then take actions. And for Reflection Agent, let the agent evaluate and improve its own answers before finalizing. So graph pattern follows as nodes, reasoning plus tool calls for the React Agent. Now edges are mostly used for the decision making, conditional edges depending on the tool results. Now Reflection Agent, nodes are the draft, reflect and revise. These kinds of nodes are used, and edges loop until answer is good enough. So reflect and revise will be continuously looped through. The strength of React Agents are it handles tasks requiring external knowledge or tools. So when you need to make an API call through tools, so it's more useful. Dynamic decision making and good for agents that interact with the APIs or multi-step workflows. Now for Reflection Agent, strengths are it produces high quality refined output, reduces hallucinations and errors. So as you know, hallucination is a major problem in LLM outputs. So through multiple iterations, it can eliminate the hallucination and error. So this is good for writing, coding, summarization or reasoning. More prominent use cases for React Agents are query a database, then explain the results, use a web search tool to answer the factual questions. And Reflection Agent, so write an essay, then improve clarity, generate Python code, then fix bugs based on the reflection. So it will create an initial Python code, then it will reflect based on the given output, given feedback, then it will fix the bugs or improve the code. Then finally, after some iterations, when result is satisfactory, then it will end the loop and finally generate the answer. Now in the demo, we'll be creating this kind of graph. So where we'll in the draft node, we will make a LLM call for the given user input. We'll make an initial draft. Then our reflect node, we will reflect that whether that initial draft is good enough or not. So we'll take the feedback. Then based on the given feedback, we'll revise and write that particular text again. Now again it will go back to the reflect. Now again we'll take the feedback, and if the feedback is satisfactory, then it will end. If it is not satisfactory, then it will go back to the revise node, and it will improve the response based on the feedback, and then it will again go back, that it will reflect, and then again it will check the feedback is satisfactory or not. If the feedback is satisfactory, it will end. Now let's see it in demo. For this particular project, we'll be using these 4 dependencies: LangGraph, Python.env, LangChain, and LangChain OpenAI. LangGraph will be used for creating the graph, and Python.env will be used for loading the keys from the environment files. LangChain will be used for LangChain based dependencies, and LangChain OpenAI is the extension of LangChain, where we will be calling some OpenAI functions, and we will be calling LLM, and here we'll be using OpenAI. So we need OpenAI API key. So OpenAI API key we are storing inside .env. Okay, so you need to store it in this format. So we need to give a key like OpenAI API key, and then let's see that code one by one. So first we need to create a schema. As you have seen it in the earlier versions, that in the agent state is used for storing the state of the graph. So this state will be used as a memory for the entire agent, and we have these many properties, that is draft, which is a string. It will be used for storing the initial draft. Feedback, we will store the feedback for the initial draft, and then it will user prompt will be used for getting the user prompt, and final will be used to store the final output. So, and we are using one more variable called count. So what we'll do for the count is like, so that loop does not continue for infinite times, so we are giving the maximum number of loop can happen is 3. At max it can go for 3 iterations. So it will kind of take feedback, improve, take feedback, improve, take feedback and improve. But if it is not satisfactory enough, then it will end after 3rd iteration. So next Python file we need is nodes. We are just loading the OpenAI API keys from the environment file .env, and then we are creating a LLM call, that is, and we'll be using GPT-4o mini. Now these are the 3 nodes that we'll be using. One is draft node, one is reflect node, and another is revise node. And then there is a conditional age condition, that is the feedback condition, that will come after explaining these 3 nodes. So what is first draft node is doing? It will take an input, the right concise answer to the question, and it will take that particular prompt. So based on the given user input, it will generate a response, that it's making an LLM call, and then final response we will be storing it inside the draft. So this is the initial draft based on the what user has asked. Now we'll be simply printing it, and we are initializing the counter to 0, and we are returning the state here. Now next is reflect. What reflect does, we are giving a prompt, you are reviewing the following text for errors, clarity and completeness. Now we are passing the state draft that we got it here, right? And provide a short critique of issues, if any, or say looks good. So it will give a feedback. If everything is good, then it will say it looks good. Simply itself say looks good. Now again, with that particular prompt, we are making an LLM call, and whatever the response we are getting, and just check that we are passing the draft as well. So whatever the initial draft has been generated, that we are passing. Along with that, we are giving that particular prompt, and then we are getting the response and storing that response in the feedback, in the feedback property inside state. So next we are printing and returning the state. Now next is the revise node. What we are doing in the revise node? Revise node is telling revise the following draft versions of the feedback, and what we are giving based on the given feedback that we received here and the draft versions that is created initially, we will be revising that particular initial draft, and then we are storing it in the draft versions, and we are storing it also in the final version. So these drafts will be taken back to the reflect node, and if loop ends, then we will just show the final. How the loop will end? The loop ending condition, and here we are also increasing the counter as well and returning the state. So every one loop, it will be increasing the counter by 1. Now let's see how we are looping and what is the condition. So if it looks good, so we have given a condition, you say or say looks good, that this is the feedback. The feedback says looks good, then it will end. If it is more than or equals to the maximum steps, it will end. Otherwise it will go back to the revise node. Now conditional loop or conditional loop or feedback loop or conditional edges I have explained in series 3 in this episode 3 in this series, so you can take a look. Now we have explained about nodes. Now we will be building the graph. So for building the graph, we need to initialize it like state graph and agent state that we have defined it inside schema, and we'll create a kind of a graph object, and inside the graph we'll be adding the nodes and edges. Okay, so what are the nodes? Initial first node we'll add is draft, second node will be adding reflect, and third node will be adding revise. Now we'll add a conditional edge. Okay, so now we are creating the edge between start and draft. So start and draft is created. Now we are creating another edge called draft and reflect. So draft and reflect has been created. Now we are creating one conditional edge from where it will source node is the reflect, and the feedback conditions that we have written inside the nodes.py. I have explained it already. Now if it goes to revise, if it is the input is revise, it will go to the revise node. This one, it go to the revise node. Okay. And if it is input, output is end for that feedback condition, output is end, then it will go to the end node. Okay. Now again we are creating an edge between revise and reflect, so it will create a loop. Now finally we are compiling and it will create a reflection app. Now in the main.py we are doing two things. We will create a visual graph. For that, this code I have written. So it will create a graph after run. It will create a graph inside the output directory. And now let's see. We will take a prompt. We'll ask user to give a prompt, and then we are calling the reflect app to invoke, and it will just give the final, what is the final output, feedback, and total iterations count here. And also the intermediate steps also we are printing, so we will see it in demo. Now for the demo purpose, I'll use this text. Write a 3-sentence summary of the India's unmanned landing in Moon. So it will improve that particular text continuously over multiple iterations, and finally generate a response. Let's see it. So it's asking enter the prompt you wish to revise. Now says write a 3-sentence summary for India's unmanned landing in Moon. It will take some time. So initial draft it has created India's Chandrayaan 3. Let's see that Chandrayaan 3 successfully achieved an unmanned soft landing on the moon on August 23rd, 2023, marked India as the 4th country to land on lunar surface, etc., etc. Now let's see the feedback. So now feedback has been generated. The feedback has been generated, and it says the draft is clear and concise, effectively summarize India's Chandrayaan 3 missions and its significance. However, these types of improvements are required. Now we'll take that feedback and the initial draft, and then we'll try to improve. Okay. Now what it does? Now revise draft here. Now what it does? Now revise draft here. The draft has been revised and it has improved. You can take a look. It has improved the initial draft. Now Again it iterated, and again it took the feedback that what is the feedback for this revised draft. Now this is the feedback, and based on the given feedback, again we are revising the draft versions. Now draft has improved. Now similar to that, we are continuously iteration 2 is happening, and finally we have generated the final response, that is the final output has been generated, and it says this is the final output, that is the revised draft. And so it ran for all 3 loops, and it created a final output like this up to this. And you can see that it has again given a feedback, but as the loop has ended, it reached maximum iteration, the loop broke and came to the end node, and finally it stored the graph inside the graph.png, and you can see it here. So initial draft has been generated, the feedback we get in reflect, then we took the feedback and the draft versions we revised, then it went back again to the reflect, and it looped through for 3 times here, and finally it came to the after 3 times, because that is the maximum number of loops were allowed, it came to the end and it ended here. So this is how the reflection node works. This is the end of the demo for the reflection node, but in the next episodes are going to be very interesting. We will be creating a Streamlit app with the LangGraph, and tracing with LangSmith we will be doing for the production grade agent building. So stay tuned. So if you liked my video, please like, comment, share and subscribe. Thank you for watching.